Okay, so let's do a little application of the trigonometry ratios we just learned. How tall is the Christmas tree? And you can also tell how tall a tree is out in your yard with just a little bit of work and a little bit of know-how. You could count your steps from the tree out and know a distance how far. Most people, their shoe is about a foot unless you're really tiny or have a really big foot. Some people actually have tape measures and you can measure it from there. But how far straight out, sort of from where the middle of the tree would be straight out. And if you want to know if it's going to the tree's going to land on your house, let's say, oh, we're worried about the tree falling over and hitting the house. It's close, but is it really going to hit? So what you could do is figure out how far this is and then calculate the height of the tree. And it's not that hard to figure out because you now know how to do trigonometry. All right, so let's say this girl wants to know the height of the tree. All right, might have a little special effects there, yeah. All right, so she's going to be standing. Normally, you look at a line of sight which is straight ahead, okay? Well, her normal line of sight is straight ahead, which would be like right out through here, but now she's looking up to the top of the tree to right here. So that's now her new line of sight going up. So you're normal, you don't look straight down when you're walking, you look straight ahead. And then she needs the angle. Well, you can take this little device. They make them, but they can also take them, and then probably there's a way to do it on your phone now. There's probably an app for you to use to figure out the angle, but we'll have to see. I don't know. And figure out the angle that's going to go up in there. And hers is 28. And I'll show you in class how you could make something to do it if there's not an app for it. So the angle from where she normally is looking ahead to now to the top of the tree is 28 degrees. She wants to know the height of the tree. She's 50 feet away. She counted it out. And she wants to know the height of the tree. Is that going to give her the height of the tree? No, it's only going to give her the height of that triangle right there. But that's a start. So let's find that. This would be the opposite. This down here, here's our right angle with the tree standing straight up. And this will be the hypotenuse, which we don't have, but we do have this bottom, so that's adjacent. So that's going to be tangent of your angle equals the opposite over adjacent. And that works out to 26.59 feet. So far the tree is about 26.95 feet. I know it's not drawn to scale, but you get the idea. Now, that wasn't the whole height of the tree, remember? That's only to right there. Why is it not including all this bottom part right here? Because she's not laying on the ground looking up. Now, if she was laying down here looking up, then yeah, that would be the whole height of the tree. But she's standing up. She don't want to get her clothes dirty. She doesn't have to because her line of sight, where do you look from, your eyes, she can figure out pretty easily her eye level height straight up to her eyes, not the top of her head, right? And say, let's just round it off, it's 5 feet. Now we can take that 5 feet and that'll be just straight up extra 5 feet that would have made, see how it's like a big rectangle right there? That opposite end matches. So add the 5 feet on to your 26 and you're going to get 31.59 feet for the height of the tree. Okay? That looking up is called an angle of elevation. So that's your angle of elevation because you're looking up, elevate up. Angle of depression. Yep, this has great sound effects. Made them years ago when computers had mice running them. Okay, yeah, no. All right, so these guys are going fishing. Yep, they got a pole, they got a hook, no bait, but guess what? It doesn't matter. Here comes Jaws, and he wants to get on the hook. All right, so they have devices that actually use trigonometry in them and a little sonar sound waves to calculate how deep the fish are underwater. So if there's a big school of fish swimming around and people that are real serious about fishing, they have these little devices you stick down the water. It sends out a little sound wave and it tells you, oh, there's something in the water right here, like a bunch of fish or a school of fish or something. So, alright, but it does make, when you think about here, there's your right triangle, and you could actually calculate maybe a little vertical angle here with these two, and so you could find your angle of depression looking downward, going down. So this angle of depression would be here. So here's my right angle. He let out 100 feet of line off this thing, and his angle of depression is 62. So how deep is the fish underwater? All right, that's what we're going to calculate. So what formula would that be? Okay, opposite to the 62, hypotenuse, sounds like sine. All right, you know what to do. Put it over 1, cross multiply, and the fish is 88.29 feet underwater. So what's going to happen? Dun, 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 dun. Okay, I hope y'all have the sound up there. Okay, one last problem. Making sure that you understand about angle, elevation, depression. The girl on top, note she's not going to jump, okay, is looking down at her friend down the ground. Now, we're not going to make her lay down the ground. We're not going to make this one lay down the ground. But technically, let's just say they're looking from the very bottom on up. All right, how tall is the building? This girl is 100 feet away from the building. That's easily measured. She's looking down, and let's just forget about the eye level for right now. Let's just say that she's straight on the edge of the building. Where's the eye level height? Her normal line of sight is out here. Her eye level height, excuse me. Her normal line of sight, okay, is straight out. Her angle of depression is supposed to be 50 degrees. Now, is that going to be right here, or is that going to be right here? Angle of depression is coming down from her normal line of sight. So this is the normal. So it has to be 50 degrees right here and not right here. Now what you could do, if you thought about it, the normal line of sight is parallel to the bottom where that 100 is. You ought to be able to figure out this angle without too much trouble. What is that called? Alternate interior angles. Oh my gosh, you mean we got to use that again? Or you could say, hey, the opposite side's going to match and put your X there. And that would be your problem to work out. It'd be 100 at the top, everything opposites match there. So, or, hey, triangles make 180, you could put 40 up in this point. Right? So, angle of depression, you have to watch for it. It's from the normal line of sight coming down from there, not just down. Alright, so